Good afternoon, everyone. My name is Simranjeet Benepal. Today I am presenting the Greenpeace security policy. This presentation explains our coding standards, security principles, testing methods, and how we can protect our system using a defense in depth approach. This slide explains the concept of defense in depth and why multiple layers of security are necessary. It shows one layer of protection is never enough. This diagram shows how different parts like app security, endpoint security, network security, and cloud security and physical security all work together to protect system and data. Each layer has its own job. For example, app security uses things like secure coding, encryption to stop bugs and attacks. Endpoint security protects devices like laptops and phones using antivirus and patching. Network security uses firewall and VPNs to block threats from outside. Cloud security makes make sure our data is safe when we use online services. Physical security protects buildings with things like cameras and access control. This slide presents a threats matrix showing the severity and likelihood of different coding risks. It explains which risks are high priority, which are common, which are low impact, but still important for the code quality. Here we have 10 secure coding principles. Number 1, validate input data. Make sure all input is checked so unsafe data cannot break the program. Number 2, heed compiler warning. Warning helps catch mistakes early so they should be always fixed. Number 3, architect and design for security. Plan for security from start so the system is safe before it's built. Number 4, keep it simple. Simple code is easier to understand and easier to secure. Number 5, default deny. Block access unless there is a clear reason to allow it. Number 6, least privilege. Give every user and program only the access that's truly needed. Number 7, sanitize data sent to other systems. Clean and check all data before sending it to anywhere else. Number 8, defense in depth. Use many layers of protection so one failure does not break the system. Number 9, use quality insurance techniques. Use testing tools and review to find problem early. Number 10, adopt a secure coding standard. Follow clear rules for writing safe code so everyone works the same way. This slide summarizes the 10 coding standards used in the policies, such as use fixed width data types, always initialize and check data values, use safe string functions, prevent SQL injection, protect memory and use it safely, use safe assessments, use exceptions for errors, pointer safely, use proper memory alignment, validate all user input. So each standard explains how it prevents common vulnerabilities. This slide explains encryption in flight, at rest and in use. It describes how TLS protects data during transfer, AES 256 protects stored data, and secure memory handling protects data while programs are using it. This slide covers authentication, authorization, and accounting. It explains how strong login methods, access controls, and activity logging work together to secure system and track user actions. This slide is introducing the coding vulnerability tested, out of range vector access. It explains why this vulnerability is dangerous and how unit tests were used to verify safer behavior and error handling. In the next few slides, we're going to do four unit tests. and I'm going to explain one by one. This is the test number one. Can add to empty vector. So this test checks whether adding one value to an empty vector works correctly. So it passed, confirming the vector updates from size 0 to size 1. This is test number 2. Does adding 5 values increase the size correctly? So this test verified that adding 5 values increased the vector size to 5. So this test passed, proving that the vector grows correctly. It's a positive test. This is test number 3. Does add function throws an exception for an out of range index? So this test checks whether add function throws an exception when accessing an invalid index. So this test passed because the accepted out of range exception was thrown. It's a negative test. This is test number 4. Does clear function erase all values from the vector? This is another positive test which verifies that the clear remove all values from the vector. The test passed, confirming that the vector becomes empty and size returns to 0. This diagram shows how security is added to every step of building and running software. It's called DevSecOps, which means combining development, security, and operations into one process. Let's break down two circles. Pre-production, before release. Access and plan. Look at the new threats and rules and then update plans. Design, build the app with security in mind using best practice. Build, use safe code and trusted tools to create application. Verify and test. Scan for the problems and test the app to make sure it's safe. Now, after release, when the application is in production, so transaction and health check. Set up app and test for weakness, monitor and detect. Watch for attacks using logs and alerts. Respond. If something goes wrong, block it or roll back to safety. Maintain and stabilize. Check the system and return to the safe state. This slide describes the diagram from previous slide and adds the explanation I just went over. For example, explain the DevSecOps pipeline and the tools used at each stage, including CPP check, client TD, SonarQube, Valgrind, Wasp, Zap, Burp Suite, CM systems, and incident response tools. Here are the risks and benefits. It discusses the risk for delaying security and benefits of early testing and automation. It explains how secure coding reduces crashes, data leaks, and maintenance cost. Let's talk about some recommendations. It identifies gaps in the current policy such as outdated standards, lack of third-party code rules, and missing training requirements. It recommends regular updates, code review, automated scanning, and stronger training. In conclusion, the slide explains that secure coding should be part of our daily work. It highlights using safe data types, checking input, doing code review, and using automated scans to stop problems early and keep user data safe. Thank you very much everyone for watching this video.